This is part 2, year 10s of the finding side length using an angle for exercise 4a. It's highly recommended that you watch part 1, but if you feel confident and you just want to jump straight into the examples, you're more than welcome to watch part 2. If it doesn't make sense, definitely go back to part 1. And we're going to look at 4 different examples using the sine, cos, and tan trigonometric functions that we just discovered or I've introduced to you. And you can see shorthand how this is used in conjunction with your scientific calculator. It's highly recommended that you use this when you answer these questions, else you're going to have one tricky time without it. Now, before we get into the questions, I'm going to just talk about this little notation here, which is called Sokatoa. Sokatoa. In part 1, we looked at using if the opposite and the hypotenuse side of a triangle was provided, or a side of interest, then we use the trigonometric function sine, which is here. And so sine of that angle is equal to the opposite divided by the hypotenuse. If the adjacent and the hypotenuse are our sides of interest, then we use what's called the cos of the angle, which is adjacent over a hypotenuse. And if the opposite and the adjacent is provided, or our sides of interest, then we use what's called the tan of the angle. And this is equal to the opposite over the adjacent. Now, why is this spelt as sin but pronounced sine? Well, to answer that question, this is actually sine with an E at the end. And when mathematicians use shorthand notation, they just reduce it to 3 letters. They just drop that E, but out of habit, they called it sine. So it's not the sin of an angle, it's actually the sine of an angle. That's what it's called. And sine, when you think of sine, you think of sinus, so like the nose. But a sine wave is essentially something that looks like that. You probably were wondering where this curved line comes from if we're dealing with triangles. Now, there's a lot of behind the scenes when it comes to working with this, but when this somehow can be graphed, the sine of an angle, it creates this curvy line. And here you can kind of see what looks like a nose. That's why it's called sinus, because it comes from, or derives from the word sine. Cos comes from the word cosine, which kind of looks like the first word. You can see the first word sine in there. Co just means in relation to. Okay, there's a relationship between the two. So sine and cosine are very familiar, dependent on whether you've been given the opposite or whether you've been given the adjacent. But the hypotenuse stays the same. And tan is just shorthand notation for tangent. And tangent just means to touch something, and touch at specifically one point. Now again, this has to do with graphing these trigonometric functions, which we're not going to look into at any time soon, unless you want to do math methods unit 1, 2, and 3, and 4. Then you will see how these work via graph. But for now, all you have to care about are these trigonometric functions, and there's only 3 of them to use, okay, depending on what signs have been given. So let's look at this question here. Find the value of x in these right angle triangles, and we know they're right angle because they've got that little square there to indicate that it has 90 degrees. And we're going to correct this to 2 decimal places. And the first one here, we're looking for this length here, which is x. We don't know what this length is, it's in centimeters, but what we do know is that the angle in here is 27 degrees, and this side here is 11 centimeters. Now the first thing we want to do is we want to label the graph. And we're going to specifically label the sides that we know in relation to these two angles here, the 90 degrees and the 27 degrees. Now we know that the angle 90 degrees, the line opposite that is called the hypotenuse. And I'm actually not going to write HYP, I'm just going to write H for short. Okay, H. So the hypotenuse side has been provided. Then this 27 degrees This is the angle of, the line of interest, or the side of interest that we're trying to figure out. And this is next to the angle or adjacent to it. It is adjacent, so we're using A. So the second step is now trying to figure out which function do we use? Which trigonometric function do we use? Provided that we have got the adjacent side of that angle and the hypotenuse side of that angle. So we're looking for any of these trigonometric functions that has an A and has an H and only has an A and a H. Can't be sine because it has an O and a H. And it can't be tan because it has an O and an A. It has to be a cos. And this is where that Sokatoa comes into play. You think so, ka, A-H-R, ka, cos, C for cos. So which function? We use the cos function. So we're using the cos of this angle is equal to A over H. The next step, sorry, I just had to take my doggy out to use the toilet, or aka the lawn. Okay, so where am I? The next step is once we've labeled and we've discovered which function, figured out which function that we need to do, the next step is to substitute what we do know. Now we're going to substitute and sub what we know. And what we do know is that for this exercise, we're always going to know what an angle is. Okay, we always are going to know what the angle is because we're finding a side length using an angle. It says it in the title. So no matter what we do, we are always going to put some trigonometric function, sine, cos, tan, and we're always going to put that angle that's been provided. So cos 27. And we know from the two sides, the adjacent and the hypotenuse, only one of these sides have been provided and the other one is what we're trying to work out. In this case, the adjacent is the side we don't know, but the hypotenuse is the side that we do. And so what we end up with is cos 27 degrees is equal to x over 11. So to give some insight, what is cos 27 degrees? Cos 27 degrees is equal to 0.89. This is just saying that some number divided by 11 has to equal 0.89. Or in other words, this 27 degrees, if this was 27 degrees and this line here is 11, this x degrees, centimeters has to be some line, and there's only one length that this can be, provided that this is 27 degrees and this is 11 centimeters. If this number changed or this number changed, then our whole answer will be different. But in this case, 27 and 11, we need to figure out what this side length is based on those two. So whenever we get to this part here, we're now going to solve for unknown. Solve for unknown. This is our final step. Whenever we get to the situation where the letter that we're trying to figure out is on top of the fraction, all you need to do is grab the bottom number and multiply it with the trigonometric function. Or in other words, our x value is equal to 11 multiplied by cos 27. That is all you do, no matter what these numbers are, no matter what this length is, no matter what this degree is. If the letter is on top, you just multiply this by this to get your x length. So on your calculator, you would put 11 multiplied by cos 27, and that will be 9.80. 9.8. You don't have to, 0, and it's two decimal places, so it's just 9.8 centimeters. this is the only length that this can be here, okay? Because if we put, let's look at it this way. If we put 9.80 as a fraction, yeah, that's right, it doesn't work as that. 9.80, 9.80. No, it's not going to be exactly, it's going to be very close because we rounded. But if we put 9.80 over 11 as a ratio of one or the other, that's going to be very close to 0.89, which is what we got as cos 27. This is why we use this cos 27. That's what it's saying. That's how we get that number here. Okay. So in a nutshell, we label a triangle. We figure out which function we need to use from that labeling. We substitute what we do know, and then we solve for that unknown. So that was for A, and that's our answer. And then once you realize these 4 steps, once you get the hang of it, it's actually quite simple to try to solve for an unknown. So let's get a bit quicker with this. Let's look for what we do know. So we've got an angle here. So angle's been given. This right here is opposite the angle, and this is what we're trying to figure out. And this line right here is adjacent. It's next to. Okay. We don't need the hypotenuse in this case. We've got the opposite and we've got the adjacent. So step 2 is saying, which function do we use? Anything that uses an O and an A is the tangent or the tan of that angle. So what we can write in is the tan of 69 degrees is equal to the opposite, which is x, over the adjacent, which is 38. Now, in the previous one, I wrote what the function is just as, okay? I've jumped straight to the next line because I can just substitute that for there, the adjacent here, and the opposite, which we don't know for here. Again, this line that we're trying to figure out is on the top of the fraction. So if this is the case, all we have to do is multiply the bottom number by the trigonometric function itself. So 38 times tan, 69 degrees. Right. So we substituted what we know from here, and now we just got to solve for that function. So x is equal to 38 times tan 69 degrees. Now just be careful whenever you're putting in your trigonometric function, just out of habit, close that bracket. Most of the times it works without it, but sometimes when you get complicated numbers in the system, just close the bracket. Just makes it easy, okay? Easy for your calculator to work it out. In this case, 38 times the tangent of 69 is 98.99, and it's rounded to 2 decimal places. So look at the next one, that is a 3, so this is 98.99 millimeters. This is the only number that this can be if this is 69 degrees and this is 38, or the adjacent side is 38 millimeters. And that's all there is to it. Okay, we just do these 4 steps. And now you can see that you might not understand where the sine, cos, and tan come from, but you can understand how it is used to solve one of these sides, provided that we got another side. The next type of examples we're going to be looking at is what will happen if the letter is on the bottom. Now, I did show you this in part 1. But we're going to practice this a little bit more, and then you guys can start the questions from your log sheet. I'll just set this up now. Alright, the next set of questions, A and B, we're just going to go a bit quicker now, seeing that we do know our 4 steps that we need to use, and hopefully by now we're used to the trigonometric functions and what we need to do. The first thing we're going to do for A is we're going to label what we do know, what's being provided. So the angle obviously has been provided. We have the opposite side of that angle, and we have the side that's opposite the 90 degree, so it is the hypotenuse or the h. So out of O and H. Which trigonometric function uses O and H? We can go back. O and H is sine. So O and H is the sine, so sine, Sokatoa, so sine. So the sine, let's go back, let's color the sine of 33 degrees is equal to O, which is 21, over H, which is our unknown. And now this is the example I was saying before, where the unknown is now on the bottom. In this case, where the unknown is on the bottom, all you need to do is you're not going to just do that times that to get it, because that won't work. What you need to do is you just swap the x for the trigonometric function. So when it's on the top, this gets times with it. When it's on the bottom, this gets swapped with it. So in other words, x is equal to 21 over sine 33 degrees. And we will put that into the calculator, but this time as a fraction. 21 on the top and sine 33 on the bottom. Make sure you close bracket. And we get 38.56, because that number next to it is a 7. That 5 gets rounded up by 1. So it's 38.56. 38.56 meters. So that length there, the hypotenuse side, has to be 38.56 meters. And that angle there is 33 degrees, and that side there is 21 meters. All right, last question, B. We're going to label what we do know. The degree here, this one here is the opposite, and this here is next to, so it's the adjacent. We're not using the hypotenuse. You notice that the line opposite the 90 degree has nothing there, so we don't need it. Not of interest to us. So O and A, at this point, hopefully you should know, this is the tan, and the tan of 53 degrees is equal to opposite over adjacent, or 71.3 over our unknown. Again, we just swap if the unknown is on the bottom. So our x is equal to 71.3 over tan 53 degrees. So our x value in this case, as a fraction, 71.3 over tangent, or tan, of 53 degrees. And this here is 53.73. 53.73 centimeters, and that's our x value. So by now you should hopefully understand the essence of how we use the cos, sine, and the tan. And all this is saying is that the opposite divided by the hypotenuse of these two side lengths has the same property of getting some new function, or some new function that's applied to that angle. If you give me one of these sides and the angle, I can provide you with the other side, because there's only one length that can be. Now you can research the table of sine, cosine, and tan, and all the different values that are obtained. You can use YouTube to look into how they discovered sine, cos, and tan, and what mathematics goes behind it. Very complicated stuff. But for now, just focus on the questions that you need to do. So finding side length using an angle, exercise 4a, page 269. Choose your standard, or pick your standard. I got choose and pick mixed up. Pick your standard, choose your standard to what you think suits you best, and go ahead and attempt those questions. Once you have done, upload them onto Compass. I haven't made it yet, but I'll be making a learning task for this, so you can upload it according to which exercise that you are working on. If you have trouble uploading it onto Compass, you can always send pictures of your work to me via the chat system on Microsoft Teams. And that concludes the many videos to introduce trigonometry and exercise 4a. The next videos afterwards will be a bit more easier in regards to what you need to do. But for now, best of luck guys, and I'll see you in the next video.